I'm running a little bit behind today, so we're just gonna wing it. We're gonna do Advent of Code, and we're gonna see how it goes. Let's see, Christopher Biscardi, Advent of Code. So I've been doing Advent of Code for about 4 years now. We'll make another directory for 2021. So Advent of Code. If you don't know what Advent of Code is, it is basically an Advent calendar, right? So if we go here, we see 25 sort of like quiz questions or whatever, and this kind of like draws a photo as we go along in the whole process. So you click on one of these and it gives you a question that you have to do, and you can do it in any language. People do this in Excel, people do this in like Rust and JavaScript and whatever. But you do one question, you get a star. You do another question, you get a star. For the like leaders, whoever gets the very first answer gets points out of like everybody. I don't usually compete for that. I usually just try to get all the problems done. Victor Rust. Okay, so day one, what do we have here? We'll do a cargo init VCS none, because I don't need git inside this directory. And then we can just cargo run it and it'll just work. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. As the submarine drops below the surface, automatically performs a sonar sweep. Each line is a measurement of the seafloor. So this is seafloor measurements. Report indicates the scanning outward from the submarine. The sonar sweep found depths of 199. First order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times the depth measurement increases from the previous measurement. There is no measurement before the first measurement, so just count how many times it increases. I wonder if this immediately makes me think of Rust iter-tools. I think we're just going to need peek. I think we don't even need iter-tools. I think we can just do the one peek. So let's open this. And I don't want these. These aren't going to be negative, I don't think. So I'm just going to make them U16s, or it's going to yell at me. I don't really need this to have a size known at compile time. So, I mean, well, so I need it to have a size known at compile time. What I don't need is for it to be an array with a totally sized number of arguments. So it needs to go onto the stack in like a specific size, but it doesn't need to be sized on the heap in any way. One of the things that I like to do with the questions is I'm actually going to run like criterion benchmarks and stuff on the questions. I don't know that we need to benchmark today's. Today's seems a little bit, maybe it doesn't need to be benchmarked. But let's do cfloor.iter.peekable. Do we want to do this? I can do this in 2 ways. I don't know what so one of the things is I don't know what part 2 is going to be. So let's just do the simplest implementation. So let's do for floor in, actually, we make this peekable. We need a reference to the iterator. So let iterator, or let mute iterator, because we're going to have to call next, equals this. For floor in it, let mute I equals 0. And then we do 1 equals it.next, which is what we need the mute for. And let 2 equals it.peek, which is what we did the peekable for. So we're using an iterator. We're going over the whole thing. Why is it not? I don't need it.next. I do need it.peek. Basically, the problem here is that I'm consuming iterator, but I also want a peek iterator. So I need a reference to the same one. We know how big this is. I don't need for in. We'll just make this a range. I'm blanking. I clearly haven't had my coffee today. 0 to range. Expected integer found reference to usize. Yada yada. Okay, so now we have the number of items that we're going to have. We're actually not going to use this. It doesn't matter. So we're going to do the same thing that we were doing before. Let 1 equals it.next. And then we've got it.peek. And we've got match to, I guess we could do if let here, but I like being explicit to start with. Match to, I don't know, item. I guess we could do both, right? Match 1, 2. So I'm combining these two. I'm combining them so that I can match on them. So that when we have like sum for both of them, we do a thing. When we have sum for whatever and then none, we're going to do nothing. When we have, actually for everything else, I think we're going to do nothing. So I'm just going to do this. So we've got sum I1, sum I2. When we have 2 values to look at, if I2 is greater than I1, I equals I plus 1. I don't want to exit. Okay. I need to match the level of references here. So you can see that Rust Analyzer, if you're not familiar with Rust Analyzer, it is what's giving me the type inlays here. So I have I1 and I have a reference to a U16, and then I2 is a double reference to a U16 because it's peekable and it's not actually taking it off the iterator. It's just kind of like reference. So I do need to match that. You can do that in a number of different ways. In this case, I chose to just slap another reference on here, but I could also destructure here, and then I wouldn't need to do that. So if you're not familiar, you can actually destructure references in Rust, which is kind of cool. It does lead to copying, so keep that in mind, but it's usually not a problem. And it's definitely not a problem for primitives like U16. So that says 7. That should be fine. Let me go all the way down, get your puzzle input. I'll just copy this in here. U16 should be fine. We're going to read the file in. So instead of this, we are going to do fs read. I didn't implement, or I didn't pull in fs. Fs read. Is it read file or is it read to string? And we have to unwrap here. Well, we don't have to unwrap here, but like, come on. This is going to be like, we're going to fail hard. File equals this. That comes in. I'm just going to put a vec here for a second. And then Rust Analyzer will pull this in for me. File.lines.map line .parse, and then .collect. And this is going to be a vec of U16s. And I think this should all work out, but it's telling me it won't. So what do we got? 16s cannot be built from result. Yes, I get that. So we're just going to unwrap, because if this doesn't work, then we fail. No such file or directory. Did I put this in source? I did put this in source. Don't take it out of source. 1521 is what it says. So that is absolutely correct. So it works. It's fine. It doesn't pass cargo Clippy. So if you've never used cargo Clippy before, it'll do things like tell you that you can remove these parentheses, and that you probably should. It'll tell me things like replace I+1 with I+=1. So I'll just follow Clippy for the purposes of Advent of Code, or for now anyway. Let's see what else we're getting here. You seem to be trying to use match for destructuring a single pattern. Yes, I called that out when I did it. I don't know if we're going to need more in the next one, so I'm going to leave it for now. But Clippy is pretty cool. There's a reason they're optional is what I'll say. So don't necessarily feel like you have to run Clippy on all of your code, but I find a lot of them helpful. So consider every single measurement isn't as useful as you expected. There's just too much noise in the data. Consider sums of a 3-measurement sliding window. Again, considering the above example. Okay, so we have this new input. Start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A, 199, 200, 208. So it looks like they're always 3. Their sum is 199 plus 200 plus 208 equals 607. The second window is marked B, 200, 208, 210. Sum is 618. The sum of the measurements in the second window is larger than the sum in the first, so the first comparison increased. Okay, so we need to iterate over this whole thing and kind of sum some stuff up before we do the calculation. Do you think Rust is going to be required for front-end development? I know it's used for tooling now. I don't think that Rust is going to be required for like the kind of front-end development that people do day to day when they're just learning. Like you're still going to be writing HTML and CSS and JavaScript to get like document-based websites up and running. I don't think that Rust is going to replace that. Where Rust is going to be useful is if you're working on, let's say you're working on like a large project on a team with something like Next.js or something like Nuxt or something like whatever the next huge meta framework is. Those meta frameworks are going to be powered by Rust. So debugging them is going to be easier if you know a little bit of Rust. And working on them is going to be easier if you know a little bit of Rust. And then on the other side of it, Rust will become increasingly useful for things like serverless functions, which are things that we use in the front end ecosystem quite a bit to do additional functionality and things like that. Make calls to APIs, get around cores, all of that kind of stuff. I don't think that Rust is going to become required in the sense that it won't be required to build websites, but it will be a requirement if you just start going into the tooling, if you start doing more advanced stuff, if you start writing like a lot of serverless functions. Rust is really nice because it runs typically quicker than the JavaScript or like a corresponding JavaScript version does. which means that you pay less, which means that it runs faster, which means everybody's happier. But no, I don't think it's going to replace like Svelte or React or whatever your front end framework of choice is. Okay, so we got to do these windows. Stop when there aren't enough measurements left to create a new 3 measurement sum. So is it possible that we won't have like 3? Let me go check the puzzle input. Oh, okay. So it's always 3. Interesting. Okay. I thought it was going to like give us random numbers of letters next to these and we were going to have to like parse them out. But I guess it's just 3 of them. So we do need to preview 5 items. So we need to peek 5 items. Once we have an example that is only 5 numbers, then we stop. So sliding windows. Let's copy this. I'm going to make part2.rs, and I'm going to move this in here and rename this to part1. And then if we want cargo run part1, that should still work. Yeah. Okay, cool. So cargo run part2, and then this is going to be the sliding windows version. So instead of peeking once, we are going to peek like 5 times. There is also an easier way to do this. Tuple windows clones the iterator elements so that they can be part of successive windows. This makes it most suited for iterators of reference to other values that are cheap to copy. Yes, what we want. Returns an iterator over all contiguous windows producing tuples of a specific size. How do we define what size that is? Oh, it uses a type hint? That's cool. So we are going to pull this in. We're going to do tuple windows. And we'll figure out why you are a problem later. Let's turn these back into letters. E, C, D, E, F. Tuple windows. And we're done. So allegedly the number is 1611. It's not the right answer. It's too high. It's the right answer for somebody else. That's not great. Same puzzle input, right? Oh, they're not overlapping. That's why. I don't need tuple windows. I need tuple windows is what I was using, but it doesn't overlay. So like the windows aren't sliding. So basically the lesson here is that when dealing with references and not having your coffee and not realizing you're dealing with a bunch of references. So for some reason, these references are keeping everything alive, basically because when we take the mutable reference here, so we take a mutable reference to the iterator, we peek the iterator, which returns a reference to a data structure that's on the iterator, which means that if the option here is a reference, that keeps this mutable reference alive, because technically we're still looking at that thing. So when we move them here, it complains because we're moving them into the scope destructuring and adding them together. But if we just take ownership, or not ownership, but like if we just clone these values, and it's cheap to clone U16, so I'm not too worried about it, that should work. I got the same answer though, but my logic is wrong, which is hilarious. That's not the right. Am I putting this in the day 1 answer or something? All right, let's print out the test and see if we get this right. It's going to be input2.text, and this is going to be input-2. It's right on that one. Wait, is it not right on that one? 5, yes. So I'm putting my answer in for the other one, and it's not working because why? I'm not missing any here, right? So we get the next value. Then as long as they all exist, because we can't do it if it doesn't exist, then we deal with it. 618 and 716? That doesn't seem right. Why are we comparing 618 to 716? Because we're not actually doing this, are we? Oh man, I didn't do that at all correctly. This isn't even 6 values. This is supposed to be 4. Damn it. A plus 2 plus 3, and then 2 plus 3 plus 4 is the... How do we get the right number with the wrong algorithm? Oh, what a trip up for day 1. Could you do it like copy the option, like it.peek.copy, same as copying a pointer? Yes, because copy will copy the bits of the U16, which is effectively the same thing that I believe clone does for... So this should also work. If I could screw my head on straight when I woke up this morning, that would be nice. I don't think there's a sliding window function, but I'm going to look for it now. So we already have one, actually. That's hilarious. Windows method on slices. So if we don't do this, do windows, we can do... Wait, why is it complaining about windows? I don't want that. I want this. Oh, right. Expected an argument. 4. We don't need it.next here then. Don't need this match either. that come in as a slice? It does. So Windows will give us all of those, huh? Was the Windows on slices in default Rust standard? Yes. Yes, it was. If we go over, you can see it's on standard slice Windows as the struct, and the function is on the slice primitive type. Is 1543 the right answer? We're good. Everything works. This is exactly what it's supposed to be. So this works. Happy with that. Let's see, what else can we do here? I don't think that there's really any performance work to do here, so I'm not going to do criterion today. Maybe dhat. Dhat could be helpful. We could use dhat for the first time. Although I don't know that that is all going to be helpful at all either. Can I post my solution for you to look at, please? If you're done with yours, says, yeah, I'm done with mine. I'm happy to look at yours. I'm going to also order coffee. Let's do this. Cargo add dhat. I've never used this before. I want to use it on a number of the problems this year and see if I can do a little bit more profiling. I guess we do need to do release, right? So in cargo toml, our release profile will be debug 1. And then this needs to stick here. And then if we cargo build release, what is dhat? That's going to be the name of the YouTube video that I create to talk about dhat. I don't know. I don't even know if that's how you pronounce it. I just find it hilarious to pronounce it like that. Dhat as a high level thing will do some profiling to determine how much you're allocating, basically. So you'll see that when we run this, we'll get some output that's like, hey, allocated this much there, allocated that much there, that kind of thing. So if we go to target release part 2, then we get 17, so 18 kilobytes. The title is perfect. Yeah, I'm really happy with that one, actually. I need to make that video. I'll probably make it after I do it, after I use it a bunch in the Advent of Code stuff. The dhat heap JSON is viewable with dhat dhview.html. Where is dhat dhview.html? Okay, so there's an online viewer. Let's see if we can file load. Oop, that's not what I want to do. I want to use the Mac OS open. I'm in new shell. So cargo toml dhat heap.json open. Am I using new shell? I am using new shell. I love new shell. It's amazing. There's a couple of things that you can't really do in new shell, but for everything that I can use it for, which is most of my daily driving stuff, I use it. Okay, so I don't know what Gmax is. Growmax, maybe? Is it Starship inspired? Yes, my new shell theme is Starship and Night Owl colors, which is the same thing that I have in my VS Code instance. Yeah. Okay, so the dhat documentation, it looks like something that I'm going to have to read offline. The second line shows how many heaps and blocks were alive at T Gmax, i.e. the time when the heap size reached its global maximum. So for us, T Gmax happened at 258 nanoseconds, which is about 80% through our program duration. And that's when we had the most allocated, basically, is my understanding. And then T end, I guess, is when everything got dropped. Yeah, the end of execution. How many things were not explicitly freed? So we've got the maximum and the end. The total is, like we said, about 18 kilobytes in 13 blocks. I don't know that we're going to be able to do much about this particular program, but it would be interesting to compare like Nikki's solution with mine and see if they're any different at all. So we went up to a maximum of 14 kilobytes when we were running, and we only allocated 18 kilobytes total, it looks like, if I'm reading this correctly. Mostly in vector allocations, it looks like. I'm not sure what PP 1.13 stands for. The following shows a screenshot of a PP tree. The font is very small because the screenshot is intended to demonstrate high-level structure. I could just take... I mean, I have Nikki's. I could just throw it in. Let's take a look. Raw. Probably better than asking Nikki to do it because I get to use it on the same input if I do it here. So let's do Nikki.rs. There you go. So input.text. I think that the slower and more memory usage, you think? We're not testing execution performance here at all, for what it's worth. Okay, so I should be able to... Actually, I need to grab the other stuff from here. So... these get pulled over. So we changed the allocator And the allocator is the thing, like whenever you create a vec, it allocates data on the heap, right? The allocator is the thing that does that. If we use the dhat allocator, it can track whenever we do that. Doesn't matter. I used U32s. Not sure. I believe that will cause a little bit more memory usage, but like, does it really matter? Probably not. This is doing part 2, right? Read to string, parse. This is doing both. Let me recompile. Yes, it was more. So we're seeing 35K and 25K at Gmax instead of, what was it, like 18 for the other one? So yeah, 18 and 14. So it's approximately double. If I had to guess, it would be because of this collect. Because if it's just double, right, and really the only thing we're doing is allocating a vec here. So I think you have 2 copies of the vec and I have 1, probably, that kind of thing. Let's see if we can change it to a U16. I can do that for sure. Oh yeah, that would be exactly the same thing, wouldn't it? Sum is not implemented for U16, hilariously. So we would have to actually change some of the other code. Oh, sum U32 is not implemented. Why are we summing U32s? Let's do U16 here and do we need anywhere else? Part 2 data, part 1. Let's comment out part 1 because we're not doing it right now. U16 build. Okay, so it dropped. We had 35 kilobytes before. Now we have 17 at Gmax, which is, I believe, the same. So 17,947 and 17,841. At T end, mine has 0, which I don't know if that was, and at T end, yours has 1,000. Yours is consistently has 1,000 too, which is interesting. I don't know why that is. Total allocation is still a little high. It's 22K instead of 17 and 17 instead of 13 at Gmax. I mean, we're talking, just to be clear, we're talking kilobytes here. Like we don't care. Not in this instance. But it is interesting to see some of the dhat allocation tracking happening. Okay, so let's take a little bit of a look. Like any tree, it has a root node, leaf node, and non-leaf nodes. Structure of the tree is shown by the lines collecting the nodes. Subtrees beneath a non-leaf node can be collapsed or expanded by clicking on the node. It's useful to do that for subtrees you aren't interested in. It looks like we don't really have a very complex program here. So like, there's nothing for us to collapse really, except for this one root. This looks like a vec allocation. This looks like another vec allocation. This looks like a vec allocation from the FS. So if I'm reading this correctly, this is 10. That's also 10. And this is 11. So if I look at part 2 and I look at line 10, this is all basically the FS registering. So let me get rid of Nikki's solution so I don't commit their code. And then I don't think there's anything we can actually do here to reduce the amount of memory usage. And we don't do anything else. I only allocate the single vec, right? I guess theoretically there is the file that we read into a string. So we're allocating a string in a vec. Raw vec, C string on 10, string with capacity, there we go, at 10, and then vec with capacity at 11. So we have a string and a vec basically being allocated here. How big is the file? File is about 10 kilobytes, and at Gmax we have 17. If we go back and look at so at Gmax we have 17, or at Gmax we have 13 actually in 2 blocks. This is 12 bytes. This first thing that happens, this read to string, allocates 12 bytes. And then we get 9749. That is exactly the file size. That is the file. We actually can look at the allocation and match it exactly to what's actually happening. So this is the file getting pulled in. I think this is something else. 12 bytes. 12 bytes sounds to me, I don't know, like a pointer of some kind or something like that, like a really small, like, hey, we're starting a thing. And then we read the file in. So this comes in as a string as 10K. And then we have 8K from the vec. And at tgmax, the vec is responsible for 4,000 bytes. I think when we're getting this low, the only thing I'm concerned with trying to like, really we're over optimizing this. So, we are over optimizing, is actually like running into word sizes and things like that, it will be really easy for me to go this small or like on the bytes size level and miss something like that. So I think I'm happy with this for now. Reading it for today is probably enough. We have identified that there is one string allocation for the file and one allocation for the vec. It's interesting that it's 8,000 bytes for the vec, but only 4,000 at Gmax. So it would be interesting to see what was the cause of that. I wonder if we're over allocating because we're shoving a bunch of stuff into this vec, and we could maybe, if we initialized it with capacity ourselves, we might be able to cut that down. That would be probably low end use case though. But yeah, I'm happy with this. I think I'm gonna call it there. I'll see y'all tomorrow for day number 2, and I will have my coffee. You probably hit some amortization boundary, doubles in capacity each time. Yeah, that's what I was thinking too, right? Because